So we'll be talking about turbofan engine. Like we have already seen that turbofan engine is different from turbojet engine. Okay, the only addition part is fan. So like the name suggests, this is also a jet engine. It will produce a high speed jet, which is very important part of an aircraft engine. And then in addition to high speed jet, a fan serves a two three most important purposes of a jet engine. So like we have seen the comprises it turbofan engine actually comprises of a fan, a ducted fan, which is placed in front of the inlet. So the presence of a fan actually allows increase in mass flow rate of the air, and this total air which is actually entering into the core engine or the power plant, there is another part of a mass which is actually moving over the engine, jet engine, or from the surrounding of the engine. So here the total mass of air is actually divided into two parts. The first one is known as cold mass, and then the second one is known as a hot mass. Okay, so the hot mass of air is one which passes through the core engine, and the cold air is basically that amount of air which is actually passes around the engine. The amount of air, this cold mass or this amount of air which is moving around the engine, it services two three purposes. Like we have seen in the jet engine is actually very noisy because the high temperature jet which exits into the atmosphere, it produces large amount of a sound. So this cold mass, when it flows over the engine body, number one, so first thing, it provides cooling. The cooling effect is very important because the temperature we have talked about is around 1200 to 1500 in the combustion chamber. In the combustion chamber, the temperature rises up to 1200 to 1500 Kelvin. Okay, which is obviously a very high temperature. So a cooling effect is provided in order to contain the damages into the structure of the engine or the engine body. And second important thing is that this cold air actually it mixes with the hot air, and it makes the engine a little noisier. So the problem with the jet engine was noise, so here the noise part is actually reduced, plus there is an additional cooling effect. Actually here we can only see over the engine body, but then there are different arrangements made into this jet engine so that it could reach up to the compressor, turbine, and combustion chambers. Okay, and then the ratio of this cold mass to the hot mass is actually known as bypass ratio. Okay, so here bypass ratio is decided by, or the noise or quietness of an engine, it is decided by the mass which is actually passing through the core engine. Larger amount of a mass bypass will give a high bypass ratio. The turbofan engine, which is having more increased mass, actually comparatively increased mass, which is flowing or bypassing the core engine or bypassing the system of the turbine engine. Okay, it is called as high bypass ratio fan, turbofan engine. And then there is low bypass ratio turbofan. So here a low bypass ratio and high bypass ratio. The turbofan engines actually comes in two classes. Okay, if we want for low altitude and quieter engines, we'll go for low bypass ratio. If we want to reach to higher speeds and higher altitude, definitely the quieter engines will be a high bypass ratio. So it is easy to attain good speed and higher altitude, like we talked about commercial aeroplanes which fly above the cloud, where clouds are formed. So we need actually high bypass ratio which will also add to increased mass flow rate. So by changing the speed of the blade or the fan which is placed in front of the inlet, we can increase the mass flow rate of this particular engine. Okay, so higher bypass ratio will have more amount of a mass which is bypassing, but then we have to balance it with the mass which is present or which is passing through the core engine, because we also have to attain certain speed. Okay, then there is another thing which is for incomplete combustion. Like we have seen, we are using after burning system. There is a system, certain length of this compressor, exhaust is actually part of this incomplete combustion, and then again some amount of mechanism of burning or actually combustion of a fuel. Combustion is basically a process of mixing of oxygen, okay, with the fuel. Okay, so we actually enlarge the length of this engine so that we can have a complete combustion and produce the desirable thrust. Then when we come to performance of these engine, it is very easier to see from here that with the air speed and the propulsion efficiency. Okay, if we want to see how efficient, how the propulsion and this engine system is efficient. So when we talk about engine efficiency and speed, we can see the comparison from a jet engine. At high speeds, we have actually high efficient engines operating here with low bypass ratio. Again, at this particular time, at this particular point, if you compare, definitely high propulsive engines or jet engines, they the jet engines, the normal or pure jet engines, they will be able to attain lesser speed if we are aiming at high propulsive efficiency. If we want the engine to be very fuel efficient, fuel consumption should be less, then definitely jet engine is not the choice. The choice will be at a low bypass ratio, high bypass ratio, and then also a small amount of turboprop engines will be able to add that speed, will be attained that particular speed with fuel economy. Okay, but when we talk about engines which are going to Mach number, this is in miles per hour. Okay, so here at a 600 speed, at a speed of 600 miles per hour, if we want the aeroplane to fly, okay, then obviously the jet engine, better than jet engine, we have turbofan engines. The turbofan engines will be able to maintain fuel economy, plus it also produces desirable thrust. Then second important thing we discussed is a cool and calm, very less noisy engines will be there, which will produces less noise actually. And then even more, if we go for high bypass ratio, it is easy to reach to high altitude, desirable speed, fuel economy. If we are looking at all these performance criteria, then we will be opting for the designer will be opting for high bypass ratio engines compared to the jet engine. High bypass ratio turbofan engine to reach to fly at this particular speed. So obviously it is very obvious why turbofan engines are preferred for commercial planes, because they have to see the fuel economy, plus then we have to also check, we have to keep the speed under check. Okay, then coming back to hourly fuel consumption ratio and drag ratio with the Mach number, it can be easily seen that the turbofan engines are the best choice, because the turbofan engines actually have very less fuel consumption, low fuel consumption, and low drag at a given Mach number. So obviously this makes the turbofan engine the optimal choice if we want to reduce the fuel consumption, but we also have to have a certain speed and then reach to a certain altitude. So this is the second engine, turbojet engine and turbofan engine. I hope everyone understood the difference. Then the third and the most basic type of aeroplane engine, gas turbine engine that we have, is an engine which is placed with a propeller. So instead of fan, previously what we used to do is we used to use propeller. Now these propellers, when they rotated at a very high speed, it is also seen that they are able to produce shocks which affect the pressure, because when we talk about compressor, the job of the compressor is to increase the pressure. Okay, if the air if the atmospheric air we enter into the compressor, they will be able to attain design pressure, but because of the shock formation generally at very high rotational speed or at high RPM, okay, because we don't fly at high altitudes with the turboprop engine. Generally turboprop engine can be observed in helicopters. Okay, in helicopters they play a very important role, because they have to direct the thrust and then they take care of the airborne mechanism also. Okay, so here again the air is accelerated by means of a propeller blades. Okay, and these propeller accelerated air increases the speed, and then when it enters the stator and rotator, the pressure is further increased. Okay, but then the compressor again increases the pressure, combustion, and then it goes to the turbine. Okay, and there is no jet engines, they don't use these kind of arrangement actually. Okay, so this is the another mechanism where we have a turbine to generate the useful mechanical energy which we need in order to rotate the propeller, and we also have to rotate the compressor. So two things the turbine has to rotate, and then yeah, obviously we have to generate the lift. Again, you can see we have discussed this previously. The turboprop engines are actually the best engines when we try to fly at lesser speeds, even at a higher altitude, and we want the fuel economy. It is one of the best choice if we restrict ourselves to this particular value, which is around 300, which is close to 300 miles per hour. If we want to fly at higher altitude, then turboprop is the best choice. But when we go to higher altitudes, at very higher altitudes around 10 kilometer or 11 kilometer from the surface of the earth, at that point in order to maintain fuel economy, it is suggested that we should actually use high bypass ratio turbofan engines. Then this graph actually compares the specific impulse or the fuel cost with respect to the flight speed. So you can see that the scramjet engines actually, fuel consumption, not fuel cost, the scramjet engines, and that also per second. So we can have a look at the graph. The turbofan engine rules this particular graph. Okay, the fuel consumption per second is very less with the turbofan engine, and it is highest with the supersonic combustion ramjet engine. So high speed flow, definitely they cost the fuel, which is again very costly. Okay, so we are trying to achieve high speeds, but then the problem comes with the fuel economy. Okay, so we cannot use these scramjet engines for regular purposes, like we have commercial planes which regularly takes off from one place to another. It is very costly affair. Fine. So but optimum value you can see here we will be able to attain with turbofan, which is presented with afterburner. Okay, so afterburner is basically an arrangement which provides a second mechanism for combusting the fuel. The fuel which is incompletely burnt in the combustion chamber is burnt again into this the afterburner length, and then it is presented with the exhaust nozzle, so that the engine becomes quieter and it is able to produce the desired exhaust or exit speed. So here this mechanism is very useful because we are able to get complete combustion, but complete combustion actually lowers the fuel cost. Okay, because plus we are also able to attain speed. But when we go to higher speeds, definitely ramjet, scramjet, the fuel economy goes down. Okay, the larger consumption of a fuel takes place at the cost of a higher speed. Okay, so that's all for today. Thank you very much.